molecular formula, and we'll talk more about those in the next lesson. And then on the right is where the empirical formulas are. So it's the smallest whole number ratio. And so we have C6H12O6. And I went ahead and I've simplified this first one for you. And we can divide all of these by 6, so it would be CH2O. H2O2, we can divide both of those by 2, so this is just HO. B2H6, we can divide all of those subscripts by 2, so it's going to be BH3. And then C8H10Cl3. Well, there's nothing that we can simplify this down. So in this case, the molecular formula is the same as the empirical formula because we can't simplify it. There's no smaller whole number ratios. Okay. So the steps for finding empirical formulas. If you're given percentages, you're going to assume that you have 100 grams, and you're just going to change the percent to grams. Then you're going to convert the mass to moles. So if we have 80 grams of carbon, to convert it to moles, we're just going to do 1 mole over 12.01 grams because that's the molar mass of 1 mole of carbon. Grams cancels. 80 times 1 is 80 divided by 12.01 will give us our number of moles. Okay. Then we need to divide each number of moles by the smallest number of moles. And we're going to get a ratio. If the ratios are not whole numbers, you need to multiply all of them by a number to make them whole numbers. Unless you have a number 0.15, so like 1.15, you're going to round that down to the nearest whole number, so that would be 1. Or if you have like 1.06, 1 again. If you have a number 0.85, like 2.85, you're going to round up to the nearest whole number. And so this is going to be 3. Or if, say, you have 2.93, you're going to still round this up to the nearest whole number. But only if they're not whole numbers, and this only applies to your ratios. Then you're going to write the empirical formula by writing the numbers calculated in the ratios for the subscripts of each element. So let's take a look at this. What is the empirical formula for a compound containing 13% magnesium and 87% bromide? So we have we're given percentages, so we're going to assume that we have 100 grams, and I'm just going to change that percentage sign to grams. We have 13 grams of magnesium and 87 grams of bromine. Then we're going to convert to moles, so 1 mole over 24.31 grams. So basically you're just dividing it by the molar mass. So that should give us 0.5348 moles. Please take these to 4 sig figs. If you take them to 4 sig figs, you will not have as many issues when it comes to multiplying and rounding and that sort of thing. Bromine, 1 mole over 79.90. and this is going to give us 1.089 moles. This is my smallest number of moles, so I'm going to divide both of them by that number. So this is going to be 1, divide this, 0.5348. This is going to give us 2.036. So it's a number 0.15 or less. So we're going to round this down to the nearest whole number, which is 2. So now my empirical formula, and I'm going to abbreviate this EF, is going to be Mg1, but remember in our formulas we don't write 1 as a subscript, and then Br2. So that's my empirical formula. Okay. Let's take a look at another example. In this problem, it says that methyl acetate is a solvent used in paint and adhesives. The chemical analysis indicated the following, that there's 48.64% carbon, 8.16% hydrogen, and 43.20% oxygen. Okay, so we're going to start with carbon, then we have hydrogen, and then oxygen. We're given percentages. So again, we're just going to change that percentage sign to grams. Okay, so we're going to convert these to moles. And this is going to give me 4.050 moles. .079 moles, and then here I got 2.70 moles. So this is my smallest number of moles, so we're going to divide all of our moles by that number. This I got 2.99. And here I got 1.5. Okay, so this one we're going to round up to 3. And then remember I said if it doesn't fall into a number 0.15 or a number 0.85, you have to multiply it by a number to get a whole number. Well, 1.5, if we multiply this by 2, we're going to get a whole number, and that's going to be 3. But we have to do the same thing for all of our ratios. We can't just multiply one of them by 2. We have to do it to everything. So here we get 2 and 6. So my empirical formula is going to be C3H6O2. Okay. In our next problem, hold on, let me change this. This is not the same thing that your packet says. It says to determine the empirical formula for a compound containing 28 grams of vanadium and 22 grams of oxygen. Okay, so we aren't given percentages, we're given grams, so we can just work straight from that. And then oxygen is 22.0 grams, so we're going to divide by the molar mass to get our number of moles. And then this is going to give me 0.5497 moles. And then here I got 1.375 moles. So my vanadium has the smallest number of moles, so I'll divide both of them by that number. And here I get 2.50. So we need to multiply these by 2 to get a whole number. And this is going to be equal to 5. So my empirical formula is going to be V2O5. That is my empirical formula. And one other question that I ask you is, what is the ion charge on vanadium? If you take a look at the periodic table, you're going to find that vanadium is in the transition metals. So we don't know the charge of it just by looking at the periodic table. But if you remember from our ionic and covalent unit, we said that you can work backwards to try to find the charge. I just need to check, is oxygen a 2-? If yes, then I can work backwards, and that means that vanadium has to have a 5+ charge. So vanadium is V5+. Okay? You have practice problems on the following page. You need to make sure that you work through those. And don't forget to check out the last lesson on molecular formulas. Thanks for stopping by. Have a great day.